Okay, the recording is now in progression. Okay, so yeah, my name is Liam from Matrix. Got my colleague John Dobson here with me as well. Here's John.
Hi.
We'll be switching a little. John's probably going to deliver the majority of this webinar, and the focus, of course, today is for us to present you with our new automotive training solutions. These are new solutions that we are going to be releasing in the next few months. We're really excited about them anyway. So hopefully with one or two demonstrations later on, you'll get a feel for what we're doing here as well. So first thing, I'm going to share a screen with you. If you just give me a moment. Okay. Right, we should have the screen being shared now. Hopefully you can see that. If not, just give me a shout. But it looks like we can see that okay now. So we're going to present you this today with our new automotive electronics solutions. I will send you the slides after our webinar so that you can take a look at them and pass them on to any colleagues as well. Before we progress into that, I just wanted to give you a bit of background as to who our company are. The majority of you on this call will know Matrix, but I know that some of you may not be aware of who we are at the moment. And hopefully in this slide, I'll give you a little bit of background as to who we are. So our company is Matrix Technology Solutions. We were founded in 1993. The story began producing CD-ROMs for education, and that was for the first number of years. The internet came along, and all of a sudden, all of that resource became freely accessible online. And we had to diversify a lot. We've headed into the world of engineering, of automotive, of sciences and technology. And we're supplying, by and large, education establishments, colleges, universities. But we're also, as you'll see through this presentation, supplying a lot of industrial customers, manufacturers, for example. And you'll pick that up as we go through this today. Today we have hundreds of products offering hardware, software, and curriculum-based solutions for technical education. We're based in the United Kingdom. I know that on this call we have people from North America, from the US and Canada. We have people from Mexico, South America, the Middle East, Asia, India, for example. So we have people from all over the place on this call, but we are based in the UK. And we're a privately owned, financially stable organization, agile, flexible, and we invest more than 25%, more like 30% of our turnover each year in R&D. And that is in order to continue to develop new products for the markets that we serve. We sell into more than 50 countries now, and export revenues this year will actually comprise of more than half of the business, probably more like 60 to 65% of our income over this current financial year will come from export outside the UK, and that's a really vastly growing market for us as well. We, in countries outside the UK, sell through what we know as international agents, and we have more than 60 of these established all over the globe. If you are based outside the UK, you'll be able to find your local agent on our website, or you can just get in touch with me and I'll point you in the right direction very easily. So we develop products to serve many different markets. So within education, for example, we develop products for sciences, mainly physics. We develop products for computer science, some niche products for optics, fiber optics, and photonics. Our main areas are engineering. So we have many products for electrical and electronic, mechanical, robotics, mechatronic engineering, manufacturing engineering as well. And then we also have a nice range that sells to aviation departments within schools, colleges, and universities, Automotive is a big part of what we do, and of course that's what we're focusing on today, and electrical installations. Okay. So, before I hand over to John to take us through these new offerings from Matrix, I wanted to just give a very brief little background to those who aren't familiar with what we already offer and will continue to offer for a period of time in our automotive range of products. So we already have a number of, let's call them kits, for automotive electrical training and education. Firstly, we have our basic kit, which is known as the Electricity and Magnetism Kit. This kit contains 2 curriculum packs and a set of hardware that the students or technicians learn from. That will continue to be offered, as I say, for a period of time. We call this level 1. We then have 3 what we call intermediate kits. We call this level 2. At level 2, we have a kit for understanding AC principles in automotive, a kit for learning about motors, generators, and it also covers an introduction to hybrid vehicles. And then we have a digital electronics kit. These are our level 2 kits. Then, at the more advanced level, we have another 3 kits. These kits focus on sense and control using our automotive educational controller, the MIAC. We then have a CAN bus kit, and we have a hybrid demonstration panel. As I said, these kits will remain on offer and remain available. What we've got new is going to be added to this, and over time we'll be adding even more to that as well. Okay, so I'm going to let John take the hot seat and skip through the next slide. If you just press the next button, it will take you across.
Okay, on this next slide, Liam said we supply electronics into industry, and virtually every sort of major car and truck brand has bought electronics from us in the past, and we've done custom kits for them, and you can see some of our customers there. And I think in most of what we do is about learning about electricity, and of course there are a lot of existing vehicle technicians who struggle with electricity and electronics, and all these companies have their own training programs and allow those technicians to catch up. Okay, let me give you then an overview of the products that we are bringing out. Our basic kit is called Understanding Electricity, and we're just changing that a little bit. It's going to be called Automotive Electricity. It's exactly the same kit as the LK9071 is our sort of product code, but we're adding a few bits. There's relays and solenoids going into it. In the past, kind of what we've done with electronics is we've basically made for the automotive market a variation of the kits that we provide for other markets, for schools and for colleges. But what we're doing now is doing really specific manuals and products for the automotive industry. And of course, fault finding is the key thing that the automotive market wants. And so there's a large pack on fault finding, which I'll deal with later. Now on the right, you can see the academic level. Now this is a UK terminology. Those first 2 kits are what we call level 1 and 2. And to give you a steer of what that is, here in the UK, the government has equated vocational and academic courses in grades of levels 1 to 7. Level 1 is something like an 8-year-old, level 3 is a 16-year-old, and level 7 would be a PhD. So level 3 is a 16-year-old, is a sort of the middle ground there. So those first 2 kits, level 1 and 2. We've then got a pack which is a variation on an existing pack called Automotive Motors, Generators and Charging Systems. And that really, there's not a huge amount of new material there. It's basically a combination of stuff we've done before. The next one is Automotive ECU Architecture and Logic. Now, In the past, we've had a unit called the MIAC, which has basically behaved like an automotive ECU. And that's been quite popular, but it's quite an expensive item. And so what we're doing in this pack is we're really cost reducing that. We've made a special Loctronics component that fits on a baseboard. And we're also changing a little. Here in the UK, logic gates have been in the curriculum for quite a long time, and actually they're still there, but we think that it is time to do away with specific logic gates, but deal with logical functions. And so there's quite a lot of change in that product, and I'll run through that a little bit. We're doing a special product which is just about using oscilloscopes. I'll show you what that is. I don't have a prototype with me today, but basically what that does is it just generates lots of signals and allows students to practice triggering oscilloscopes and looking at waveforms. And the last one is, I'm not quite sure about that level. It says level 4. It might be level 3 or 4, but that's a product called Automotive High Voltage Battery Circuits, and that deals with batteries and charging and so on. And I'll demonstrate that to you later. Okay, so that's an overview. As Liam said, all the existing products will be available for a while. Quite how we do that, we're not sure, but my feeling is that eventually those products will be superseded by the products I've just shown you. But for now, the products that will remain the same is our automated sensor control with a MIAC and our CAN bus system. Nothing is going to change with that in the immediate future. Okay, let's look at some new bits of technology that we've developed that are allowing us to teach all of this. This is a sort of plan view drawing. I have one here, I'll show you in a minute. But basically, it's about a foot long, and it's got two 50-watt motors, and they're coupled together. And it's got a DC motor and a brushless DC motor. And the DC motor works off anything up to 24 volts. You can drive it from a separate power supply or from some batteries that we have. Each motor acts as a load to each other, so you can drive it from the DC motor or the brushless DC motor. Now the DC motor also acts as a DC generator. So if you use the brushless motor to power the DC motor, it makes DC. Correspondingly, if you use the DC motor to power the brushless DC motor, it makes three-phase. So the key part of this is we've now got a small three-phase desktop generator. And you can do all sorts of things once you've got that three-phase power supply. Now, pretty much all alternators in vehicles and trucks are three-phase. It's not always apparent because it's rectified and smoothed on the rectifier, which is often embedded into the alternator, but we're able now to teach about three-phase. And this brushless motor, it's kind of a revolution in terms of motor technology in the last 10 years or so, and a lot of drivetrains and motors in vehicles are now brushless technology. It has a big advantage that its power to weight ratio is far better than any other electric motor. And you'll see that when I show you the actual device later on. The brushless motor is probably about a quarter of the weight of a DC motor with the same power. The output frequency in terms of three-phase is dictated by the speed of the rotation, and the output voltage is also dictated by the rotation speed. There is a small plastic cover between the two, so there are no moving parts that students can get hair or ties caught in. On that platform, there's also a brushless motor driver unit. So with DC, you can actually create a three-phase signal that will then drive that brushless motor. So you've got two different motors there coupled together, and you can drive both of them, and both of them act as generators as well as motors. Okay, the next couple of components we've got is these are up and down converters. A key part of electric vehicles is converting one voltage from another. And these are called up converters, down converters, or simply just inverters. And we've created two. They sit on the back of carriers. One converts a voltage from 5 to 24 volts, and the other converts something like 24 volts down to 8 volts. and you can see the specifications there. And we're using these in the high voltage and batteries package to show the different topologies of how different parts of vehicles connect together. Fault finding we wanted to do much better than we've done it in the past. And when we're dealing with electricity, very often one of our sort of jobs, if you like, is to teach students about the terminology of electricity. And so what we've done here is we've just simply made a few new components with just the corresponding words of the fault. And the idea is that you can take a circuit, and you can take a link out, and you can put that new component in to show it's open circuit, or you can put corrosion in at a point, and the corrosion and bad earth are just resistor values that we've chosen that make sense to the experiments that we're doing. So nothing revolutionary there, but we think that's just a nice way to allow you to teach lots of faults and insert lots of faults for students. I mentioned earlier that in ECU and digital, we've cost reduced a lot of the teaching there, and we've done that by making a small computer device which sits on this double Loctronics carrier, and basically it acts like a small ECU. So it's got 4 inputs and outputs. It's got a little LCD there. There's some switches on the surface of the unit so that you can select anything up to 20 programs. You can reprogram it if you want to, but I don't think many will. And we're taking some of that sense and control curriculum and putting it into this new pack, which will be much cheaper. Okay, one of the most significant things we've done is we need to teach, we feel, much more about how batteries work and how different types of batteries work. So what we've done is we've come up with 2 new components, a sealed lead acid battery and a lithium ion battery. The lead acid batteries are 6 volts and deliver about 2 amps or something like that. The rating there is 6 volts at 1.2 amp hours. And the lithium battery is 3.7 volts, and that delivers about 2.5 amps. Now, there's a problem here in that batteries are really like little small bombs, and you've got to be very careful how you use them. If you overcharge them, then they can get hot and even explode, and it's just nasty stuff. So what we've done with them is we've then encased them in stainless steel, and that makes them very safe. They're also fused so that the current can't be too great. The lead acid in particular delivers huge amounts of current, and so they're internally fused, and their fuse rating is such that nothing is going to get damaged. It's a double problem almost, this. You don't want to damage the battery, and you don't want to damage the things that can be connected to the batteries, in particular motors and other things like that. So they're configured so that they're safe for the experiments and the use that they're going to be put to. There's another component we've had for a while actually, and it's used in electrical installation. One of the problems in fault finding, of course, is that if you're not careful, you're going to be blowing fuses all the time. So this is just a small circuit breaker, and it's used in the place of a fuse in a number of the fault finding experiments. So just to recap our goals then, obviously students need to learn how to repair vehicles. We obviously acknowledge that they're going to have to work on real vehicles at some point. And our goal really is to help students understand the technology so that when they start to work on a real vehicle, they've done an awful lot of the underpinning theory, and they're able to understand quicker how those vehicles work. And we achieve that through the provision of good educational resources, that's equipment and the workbooks. Okay, looking in a bit more detail at some of those packs then. This is our basic package, automotive electricity. The only difference between that and the current one is that it's now got some solenoids and relays including in that kit. Other than that, it's exactly the same kit. It's level 1 and 2. It's dealing with all of the basics of electricity: Ohm's law, voltage and power, DC current, resistance, magnetism and electromagnetism, electrical units and symbols, the terminology, small DC motors, switches, solenoids, and relays. Motors, generators, and charging systems is a combination of a few bits of the current resources. So we're just combining different elements of different packs and putting it into a different solution. So there we're dealing with AC, DC, and RMS currents and voltages, the principles of driving motors and how motors work fundamentally, a bit more on electric motors, generators, full and half wave rectification and charging systems in vehicles, power supplies, Zener diodes, controlling DC motors, and we are also teaching the start of how to trigger oscilloscopes in that package. So not a great deal that's new there. So for fault finding, we sat down and had a good long look at some syllabuses and talked to various people in industry about what they wanted from that. And you can see the learning objectives there. A huge part of this is how to use multimeters, and also how to use clamp meters. Clamp meters have come along in the last 5 to 10 years, and they're really now very cheap. You get a great little clamp meter for £40, for $60. So the first third of this package is just how to use multimeters, and it takes it very slowly. Students get the opportunity to test every single component in and out of circuit, so they really understand how each component behaves. We then talk about the different types of faults: open circuit, short circuit, bad earth, and corrosion, and then we teach fault finding techniques, so building grids of voltages and currents, and measuring those voltage and currents, and then understanding what different types of faults do to those voltages and currents. And there's a couple of fault finding projects in there as well. So looking at a bit more detail, hopefully you can see on that screen, these little clamp meters. There's a little Voltcraft clamp meter there, and it's great because they, in terms of measuring current, you can just slip that clamp meter around a electronics link and get a really accurate reading of the current there. So you can see the graphics and the styles. We like to use Fluke multimeters wherever we can, so we've based that on a very standard Fluke multimeter. And this is just a battery, a resistor, and a bulb in circuit. We take students through quite a number of different faulty circuits, and this is, I think, the last fault finding project. And what we do here is we give them a circuit, we give them the layout in electronics, and we give them the circuit diagram, as you can see on the bottom right, and we build a scenario. So in this particular scenario, a customer complains that neither his high or low beam lights come on the left-hand side of his car. The student deduces that there are 4 possible results or reasons for this: a broken bulb, an open circuit in the headlight ground path, a broken relay, a broken fuse. Now for each of these, the students build a grid of the different voltages, and they write down what the meter test settings should be for each of those scenarios, and then they insert the fault into the circuit, and they check that they've understood what those faults might be. I've also said there's a couple of other possible causes of the fault, so they've got to figure that out. So we think that's quite a nice way of doing this. The students can put corrosion, bad earth, or whatever in there, and they can use the multimeters to check the voltages and currents that are caused by that fault. Okay. I'm not sure how much detail is going to come through there, but there you can see 6 of the pages of the workbook. So you can see here on worksheet 1 we're starting with focusing on the multimeter. We're starting with just one component or two components of worksheet 3, building up fault grids, worksheet 7, understanding how to test batteries here. So what we do is we get a battery and we put some loads on it, and we measure the voltage with different loads, and working up to worksheet 21, which is the one I've just shown you. That's another fault finding project, I feel. Okay, so that's how we're doing the fault finding product. I think the worksheet's probably going to be about 90 pages, and there's teacher's notes and everything in there as usual. Now those workbooks are free of charge. All of our worksheets are free of charge. We are pretty close to completing this product, but if you want to have a copy, then you're very welcome. Just ask Liam and he'll email a copy for you. It is still not quite finished, and we'd really love you to tell us what else you'd like to see in that package. Okay.
I just want to see if anyone, by the way, has any questions as we move through this. Then feel free to pop them in the chat, and we'll look to address them at some point.
Yeah, I've got a question here from Rob. The model of the clamp meter, I can get that for you later, but if you look at Voltcraft, I think Voltcraft's an American brand, and they've got loads of them. So just the word Voltcraft will probably be enough for you, Rob. If you look at that, I'm sure you'll find it.
Okay. And if there are any more questions, if we don't address them immediately, we will get to them before the end, I promise. All right?
Okay, next is ECU architecture and logic. This is dealing with digital and analog inputs, different types of sensor, outputs, digital and PWM, or pulse width modulation is the kind of equivalent analog output. So in there's a small motor control system that produces PWM. The use of transistors and relays, what we kind of like to do here is we're trying to show students the circuits that they're going to find inside ECUs. And inside ECUs, it's quite simple in one sense. There's a computer chip, there's either transistors and relays for the outputs, and then there's a load of inputs. There's a bit about fiber optics in here. Fiber optics are used more in cars, so we've now got a couple of little fiber optic inputs and outputs. We're dealing with open and closed loop control, and also we're dealing with faults and how they're detected automatically by ECUs. So looking at that a little bit, we've frozen, Liam. Click on that. Okay. So there's a typical circuit where what we've got is we've got a DC battery, we've got a potentiometer which is setting a value. It feeds into this small ECU, and then the idea here is that there's a thermistor here. So there's a thermistor circuit, there's a corresponding level circuit, and the idea is that the fan is turned on. This is a fan simulated by a motor. It's driven by a transistor. So when the temperature gets hotter than the set temperature, then it turns the fan on. So it's just a small circuit that students can build. They select the program, and then they see how it all works. Okay, now there's quite a few different circuits like that. As I say, a lot of this is taken from the sense and control. It's got a PWM generator inside for motors, and there you can see the kind of layouts again of the package. So we've got the basic one here is analog versus digital, and understanding the difference between those two. Driving output devices with relays or transistors. Here we're looking at logic again, so we're looking at an OR function and what the OR function means. Pulse width modulation here, and here we're driving a motor through a couple of fiber optics just to show how fiber optics are working. The heater fan control I've just shown you, and here's a brake light alarm where what we're doing here is we're monitoring the current through a bulb, and we're showing how vehicles determine whether the bulb is blown because they can't see a voltage across a small resistor inside an ECU. So it's a little current measuring device, and we're teaching students how ECUs can do automatic fault finding. Okay, high voltage and batteries. This is something that we're quite excited about because it's a very new part of electronics. Of course, this is the biggest growing area of vehicles and correspondingly training need. And we're dealing here with lead acid and lithium ion batteries and the voltages and currents associated with those. We're dealing with how to test batteries, which is really difficult. It's really not straightforward to test batteries. Lead acid batteries are relatively straightforward because their health can to some extent, or their state of charge can to some extent be determined by the voltage across them. But understanding whether your lithium ion battery is good or not is quite a challenge. And we go into that topic and explain why it's quite a challenge. We look at battery charging systems and a little bit about battery management systems and how batteries are charged by vehicles. We look at batteries in series and parallel, DC to DC up converters and down converters, speed control of DC motors using PWM again, three-phase generation rectification, automatic and service disconnect we look at, residual charge on capacitors, dual voltage batteries and vehicles, power FETs we look at for driving motors, and there's a bit about suppression diodes. Now we've had to think about how to do this and yet still how to be safe. So the maximum voltage students will come across here is 30 volts. It is not possible for students to harm themselves in this pack. And of course, we're very aware that, you know, a corresponding voltage in a vehicle will be 300 volts, but that's just not possible in a benchtop system. So we are teaching about the techniques of high voltage, but we are not using high voltages. So let's look a bit more at that. So here we have a layout where we have 6 lithium-ion batteries. Each one is about 3.8 volts, so that's about 20 to 24 volts. And we've got this motor generator pair, and students in this particular case are just driving the motor with different voltages and understanding how different voltages produce different speeds and powers in the motor. We also teach in this pack how batteries are used in series and parallel to build up much more powerful battery cells, which is how it works in practice in industry. And students can play with the 6 batteries. They can either have 6 batteries in series, or they can have 2 sets of 3 batteries in series, and so they can understand how the output voltage and output current capability is configured by manufacturers. Here's another circuit where we're dealing with up converters. So we're showing that 7.5 volts goes in and something like 15 volts comes out, and we're getting students to understand that there is a loss of efficiency in this. So they're measuring the power in and the power out, and they're using this small up converter device that we've made. This is kind of where it ends up. And this is a circuit, and I'm going to show you this in a minute because I've got it on the desk next to me. I think actually, why don't we just move straight over to that now?
Yeah, get yourself set up, and I'll.
It's all ready. It's just the camera that we need to change.
Just give me a moment, then, guys, and I will move things across. So I'm just going to stop the screen share with you and grab the camera. Okay, right, just give me a moment and I'll get this in a position where you can see clearly enough what John is doing. All right, John, do you want to...
Okay.
Okay, right, I'm just going to focus that a little for us. Right, Okay, that should be okay now. Go on then, John.
Okay. Here we've got 6 lithium-ion batteries, about 24 volts, and they're all just in series, and they just plug in and unplug like any normal electronics component. Now, what I've also got here, I've got a couple of relays, and those relays are activated by this small switch, which is fed off one of our lead-acid batteries. This is a 6-volt lead-acid battery. I've got 2 in series, which is 12 volts. One question you may have is why we didn't make a 12-volt battery. Well, they're just bigger, more powerful, and it's harder to do. But two of those make 12 volts, and in practice, inside a lead-acid battery, there are, I think, lead-acid battery cells are only 2 volts. There's probably 6 inside a lead-acid battery, but you don't see them separately. So 6 volts there, powering a couple of relays. Those relays are totally isolating the lithium-ion batteries from the rest of the circuit. And if I flick the switch, we now have that voltage, 24 volts, is being passed to this motor generator pair. So here you can see the DC motor, the brushless motor, they're both 50 watts. He's a heck of a lot smaller, right? So what I'm doing is I'm just generating 3-phase. So this 3-phase comes out and is passed to 6 diodes, which form a 3-phase regulator. So we're creating DC. There's a large capacitor here, which is smoothing that out, and then I've got an up converter. Now at the moment, I'm generating something like 5 volts DC. It's not a huge voltage coming out, and there's maybe 100 milliamps flowing. But if I turn the up converter up, hopefully you can hear that the speed of the motor has now dropped, and we're now taking more than an amp at 3 volts into there, and it's generating 12 volts to charge these 2 lead-acid batteries. So it's just, now this circuit itself doesn't exist in vehicles, but all of the individual parts do exist, and it's a mechanism of teaching students the different blocks. So we'll turn that off again. Now, what we can do, of course, is we can start to teach all sorts of faults. So one nice fault to show, actually, is just if you remove one of the diodes in the 3-phase rectifier, the system works pretty well. And even if you remove 2 of them, it still works a little bit, right? So it's great to be able to show that some faults with things like rectifier blocks are quite tricky, because if one part of it blows, there's a degradation in performance, but it doesn't mean to say it's a total disaster. And you can insert all sorts of other faults as well. So if you want to insert some corrosion here, open circuits or anything like that, then you should be fine. Okay.
All right. Okay. I'll just pop this back. We did get, sorry, I was cameraman duties then. I did see one comment then that someone couldn't quite see what was happening, but hopefully the majority of you could. It will be on the recording, what was happening. So when I provide you with the recording afterwards, you'll see exactly what John has just shown if you just skip to that part. So I apologize if anyone couldn't quite see that. But yeah, it will definitely be there on the recording. So do you want to just, have you got a couple more slides to run through, yeah, John? Okay, so that was, I think, your next, just click in the, yeah, that was your next slide.
Okay, so once again, here you can see some of the topics dealt with by this package. So charging lead-acid batteries, building larger batteries from smaller ones, looking at lead-acid battery faults, powering DC motors, 3-phase generators, and then charging system faults. Okay, so that's high voltage and batteries. This is the next product we've got, which is about teaching oscilloscopes. And that's been an interesting learning exercise for me in respect of how people do fault finding in different parts of the world. The use of oscilloscopes is really popular here in UK colleges, particularly with Pico products. And even if you look at the textbooks used by our sort of industry body, the IMI, oscilloscopes and oscillograms feature really heavily there. My feedback is that in North America, this is not the case. I'd be interested to get corroboration of that from you guys. But here in the UK, it's a big problem. And the problem is that students just don't understand how to trigger oscilloscopes. So when they get to the vehicle, trying to get a picture of or trying to grab a waveform and make conclusions from it is hard for them. And so what we wanted to do basically is solve that problem by having one device you can go to and just practice triggering oscilloscopes on the bench. So we've created this little device, and there's a little LCD display and a few switches, and students just call up different oscilloscope signals and even CAN bus signals. So it's got a CAN bus generator in there, and all it does is just allows them to practice triggering. To some extent as well, what we hope to do is put some good signals and some faulty signals in there. And we've done all of the technology, we've done an initial circuit board, we've got it all working, we've got a technique where we're able to take Pico traces and put them into the chip on the board, but it just needs another couple of months worth of work. And basically it's going to be just a circuit board sandwiched between some layers of plastic with some terminals on it. So it's a very simple product, and I suspect that the curriculum pack to go with that will also be simple. So that's coming out in the next couple of months. Okay, I think that brings me to the end of my presentation. Let me just repeat again, all of these curriculum packs, those 4 packs, are now in sort of advanced prototype form, and they're ready for you to look at should you want them. And I'd really welcome any feedback that you might have on those, particularly as to bits that we've left out, bits that you want treating differently, and so on. Okay, that's the end. Have we got some questions?
We may do. Do you want to just let me come in and have a look? Thanks, John, for that. Let me have a see. I know that I did see some questions coming in. Questions, for example, like when these new editions look great, when will they be available? I guess the answer to that is that we're still in the development mode, yet we're in the advanced stages of development. My anticipation is that it will be in the next 2 to 3 months.
Yes,
John?
certainly, yeah.
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 Okay, so in the next 2 to 3 months, we will be bringing these to market. I think quite a bit sooner than that, we'll be in a position to share pricing. So if you're interested in any of the pricing of these products, get in touch with us as soon as you'd like. If we can't provide it immediately, then it won't be long before we can start giving you the prices of these as well. Okay? Okay. Yeah, there was a few comments there about the US catching up, young ones realizing that they need to use scopes. So that's an interesting comment. Good comment, I guess. So Rob uses the oscilloscope with the CAN kit and with our CAN bus kit.
Okay.
And also on the car. Okay. Right, okay, languages. We do provide everything in English, okay? That's just a standard thing that we do is provide all of our curriculums in English. We have in the past explored translations, and I think we have a few of the curriculums translated into maybe Spanish is one and maybe French as well. But by and large, we stick to English. We don't tend to find that it's an issue, but if it becomes a problem for people, then we can talk about the possibilities. So yeah, just at the moment, the plan is to supply in English, and let us know if that's a major a major stumbling block for you. Does anybody else, if you have any questions, feel free to unmute yourself or feel free to pop it into the chat, because we'll stick around for another 5 minutes or so and just answer any questions that people have got. That's absolutely no problem. Okay, I guess when you don't get questions, sometimes it's a good thing because it shows that we've hopefully covered off everything that you wanted to hear. Yeah, it's good to hear that people like the look of these new kits. We've had a few comments coming to me both privately and publicly. Please, again, like I said, feel free to drop us an email, get in touch with me or with your local agent if you want the pricing of any of these kits, if you want a little more information, or like John says, if you want to see the curriculum packs that we've put together. We have a question here, John, about can the user load new scope tracers into the oscilloscope signal generator?
No is the answer. That's not so easy to do, and the utility to do that is a kind of internal utility only. What we can do is if people want groups of traces, we can probably do that for them. How we do that, we haven't really figured out yet. So we've got this, one of our guys has written this piece of software that works but isn't user friendly. It's not releasable. So we can do it quite quickly here, but we haven't budgeted or thought of a way of making that facility available to end users. Would you like to? I guess is the question.
I guess if they're asking, they probably
do.
Will
Yeah.
like that.
And actually, we've often thought that it'd be really useful, particularly for different manufacturers, to have their own signals on this rather than general purpose signals. We happen to be using a Volkswagen because I've got one. So that's the only reason for it. Of course, if a manufacturer wanted to donate a car to us, then probably we could change those to that brand. So if, yeah, that would be great, wouldn't it?
Okay, I hope that answers your question, albeit not in full, but you know, there's potential there for us to do that. As I say, we're kind of not yet at the final stages of this particular product development for automotive, but we're at enough of an advanced stage to show you what's going on. We have the curriculums more or less written, and we can look to share them with you. The pricing we're all but there with as well. So if you're looking for pricing on these kits, again, just get in touch. When they are officially ready for release, of course, you guys will be the first to know, and we'll be in touch regarding that too. I will share with you in the next hour or two, all being well, the recording and the slides as well that we went through, so you can send those to colleagues as required. So I think that concludes things. Thank you very much, and goodbye.